Right, let me jump in here and tell you where this came from right here. This is from the unit circle. This is just the standard, the unit circle has a maximum y coordinate of 1 and a minimum of -1, right? So this is the unit circle definition for both sine and cosine, or the upper and lower bounds, I guess. So again, that follows from the unit circle definitions. That's why the trig functions are sometimes called the circular functions. Okay, now this is a long list problem, and it's, I guess, a combinatorics problem. You're counting the number of solutions as a function of these coefficients of sine x and the constant term a sine x minus b. And it's basically saying how many times does this trigonometric graph intersect the line y equals x, okay? Now, I rewrote it like this it's clear you add b to both sides, divide by a, and you get sine x written like this. And then you use this unit circle squeeze, if you will, to determine the interval where the solutions are going to exist, okay? And you guys can follow along here. Sine x gets replaced by this, and you do some algebra on the inequality, and you get this statement right here. Okay, and so this actually gives you a solution interval. If any solutions exist, which they will, they're going to exist in this interval. Now notice the length of the interval is very important. This 2a turns out to be quite important. Notice that when you subtract this from this, the b's cancel and you just get 2a. Again, a minus b minus this is the length of the solution interval, okay? Now from there, and y'all, this is in radians, it is in radians, and so you get the total number of cycles in the solution interval by dividing by pi, right? Now, the reason why this works out, not dividing by pi, just this arithmetic right here, there's 2 pi radians in a cycle. Y'all, in a cycle is just one waveform, one period, right? And so when you do the division right here, you get that there are approximately a over pi cycles in the solution interval, okay? And I put approximately because a cycle the number of cycles is going to be an integer value. Okay, now let's move on down here. So again, we know at this point that there's a over pi cycles in the solution interval. Now this graph right here is intended to let you see that this is one cycle right here. Let me see if I can get that drawn. This is just a single cycle. Wow, steady hand here. Okay, not so steady. All right, but notice by the nature of the sine wave, there can only be 2 solutions per cycle, right? There can only be 2 solutions per cycle because it just dips, right? This is the line y equals x right here. This is some sine wave. I think it's 9 sine x. It's not really that important what the amplitude is. But in any event, you're going to have 2 solutions per cycle. But what does that tell us? There are a over pi cycles, and so what you get is a over pi. A over pi okay, times, I'll put just times 2 solutions. Two solutions. Now we do have, excuse me, a little bit of a problem here, because notice that the solutions have to be integer valued, but we can solve that problem pretty easy. So again, what we've shown is that, and it's independent, what I like about this is independent of b, right? Which would be the vertical shift coordinate. Notice there's no b in this expression, but we just have a over pi times 2 solutions, which is just the coefficient of the sine function. Okay, now let's go down and work a concrete example. Again, a over pi times 2 solutions. Okay, here we go. Now, this is the equation for this. I didn't want to obviously try to sketch this by hand, so I'll let some software graph this for us. But the green line is y equals x, and the blue guy is this 21 sine x minus 7. And that's not hard to believe. You know, if 21 minus 7 is 14, right? Which is about that value. Okay. And then let's see here. On the other side of it, you get minus 28, right? So minus 28 right here is the low end. And then plus 14 is the high end right up here. Okay, and that makes sense just with respect to what negative 7 does. It's a vertical shift, changing the magnitude of the amplitude. Now, so what we get right here is this result, 21 over pi cycles times 2, which is the result we just established. Remember, 21 over pi cycles times 2, and that's 2 solutions per cycle there. It gives us 13.36. Now, the way we get around this, let me write it up here so we can count together here. We actually just take the floor. You guys have seen this notation, the floor. You take the floor of 13.36. The floor of 13.36. I'll get it written down here in a minute for you guys. The floor of 13.36 is certainly equal to 13, right? And that will be solutions. And that's what we need, because a solution can't be obviously just, it has to be a natural number of value, right? So that's equal to 13. Okay, now let's check this thing out, folks. We can start counting down here together. Look, what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, trust me, it just, I wanted to do another graph for you guys, but it doesn't touch there. It doesn't touch like it looks. It's hard to tell from here. You really can't tell. But anyway, there are 13 solutions. Let's count backwards. I always do that to check neurotically here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And y'all, it's crazy. If you try, I went nuts trying to count these things in pairs. You would think you could count them in pairs, you know, the way it's done. But man, it drove me crazy. You know, it just did. So I'd count them one by one, as stupid as it looks. So anyway, there's our result. And that's just for this special case. Now let's go back to this original problem here. This was actually, what I did is I journalized this. This problem was what they call long listed, which I'm not really even sure what that means in the IMO, you know, but from what we just developed right here, the number of solutions, let me get a little more space here. The number of solutions would just be the floor of 1964 divided by pi. Divided by pi. And y'all, I use like the constant 355 over 113, I think, when I was doing some of my work on this. 1964 times 2. Okay, and we're doing the floor of this. Okay. And I believe I got 1250 on that. 1250. But anyway, that's whatever. I'm pretty sure that's correct. 1250. So there's 1,250 solutions to this long listed IMO problem. Way back in 1964, I believe, is why they put the 1964 there. Okay, y'all, but I guess the so-called answer to this problem would be right here. You would make this the floor. Okay. And again, that's independent. Not too surprising. The vertical shift doesn't really change anything. But that is independent. You just have A here divided by pi times 2, because there's 2 solutions per cycle. and then you have to take the floor because you want to count cycles just like you count apples, right? No decimals, okay? So that's all, folks. I like that one a lot. Hope you enjoyed it.